Hi everybody. What we're going to do now is look at a method for integration called the method of substitution. And I have the homework posted on Moodle. And I'm going to post a practice test for test 3 up on Moodle by the end of the week. But right now we're going to investigate chapter 4.5. Let's just review what we know. And also introduce a couple of terms. We know the integral and the derivative are reverses of each other. So if I want the integral of, say, x squared dx, and I have something like, I don't know, 1 to 2. I want to know the area under the curve x squared from x equal to 1 to x equal to 2. I know what I need is I need to get the antiderivative, which would be x cubed over 3, and evaluate that between 1 and 2. So I would put a 2 in for x and get 8/3 minus 1/3, which would be 7/3, right? So put in a 2 for x, I get 8/3. Put in a 1, I get 1/3. The difference is 7/3. That's the area under the curve. This is called a definite integral. There's also something called an indefinite integral. And that is where you don't put any limits of integration. You just, basically what this is saying is give me the antiderivative. And the antiderivative is x cubed over 3 plus c, where c is some constant. So if we're asked for the definite, so if we have limits of integration, that's the definite integral. If there's no limits of integration, we call that the indefinite integral, but it's also just called the antiderivative. So if we're given a power, all we have to do is add 1 and divide by that. If we're given a sign, we know how to get the antiderivative of that. If we're given a cosine, we know how to get the antiderivative of that. If we're given e to the x, we know how to get the antiderivative of that. If we're given 1 over x, we know the antiderivative is a natural log of x. Okay, so now, what if we have a function like this? Let me pick a good one. So let's say we have a function like that, x cubed plus 2x to the 4th. We know its derivative, right? To get the derivative, you have to do the chain rule. You bring the 4 down, decrease the exponent by 1, multiply by the derivative of the inside. So to get from here to here, we use the chain rule. Okay, so if we had a problem like this, what's the area from if we had a problem like this? Well, knowing what the antiderivative is, we just do this. 2 times x cubed plus 2x to the 4th. Evaluate that from 0 to 1. If I put in a 1, I would get 1 plus 2 is 3. So I'd have 2 times 3 to the 4th minus, if I put in a 0, 0 plus 0 is 0, 2 times 0 is 0. So our answer would be 2 times 3 to the 4th, which is 162. So if we had that information, that'd be easy. Now we're going to see, what do we do? What if we're just given this? How do we reverse the chain rule process? And there's a systematic way to reverse the chain rule process. So Okay, so our problem we're given is to find the integral from 0 to 1, so this is a definite integral, of 8 times x cubed plus 2x to the cubed times 3x squared plus 2 dx. Okay, so the key is to notice that this is the derivative of this. So let me show you what we're going to do. We're going to do a change of variable. Let u be x cubed plus 2x. We're going to let the u be this thing in here. So this is going to be the u. Notice that if we take the derivative of this, we get that. So instead of putting du dx, I put du and multiplied both sides by dx. You could think of it that way. Notice that this is this, and this right here, this whole thing, is du. So what we can do is simplify this integral. We can say, well, it's 0 to 1, 8 u cubed du, because this whole piece is du. This whole piece is u to the cubed. Oh, that's an easy integral, right? Now, whoops, I put 0 to 1. That was a mistake. I've got to figure out the new limits of integration. This is in terms of u, not x. So we need to figure out what u of 0 is and what u of 1 is. So let me go over there here and do that. U of 0 would be, u is 0 plus 2 times 0 would be 0. U of 1, 1 plus 2 would be 3. So our integral is okay, now that's easy. 8 is a constant, so it doesn't matter if we put it out here or in here. Doesn't matter. So we're going to have 8 times, okay, put in a 3. Oh, sorry. You got to get the antiderivative. And then we're going to evaluate that between 0 and 3. If I put in a 3, I would get 8 times 3 to the 4th over 4. If I put in a 0, I just have 0, so it's minus 0. Simplify this. 4 goes into 8 twice. We have 2 times 3 to the 4th. Same thing we got before. So even though I didn't know specifically what the antiderivative was, I can still do using the method of substitution, I can still figure out the integral. Okay, let's do another problem. Let's do a problem, chapter 4.5, number 7. So, number 7, chapter 4.5. It's asking for an indefinite integral. Okay. So, our first clue is the stuff, if this is going to work at all, the outside stuff has to be the derivative of the inside stuff in some way. So let's take a stab at it and say let u be 1 minus x squared. Then du would be equal to negative 2x dx, right? Well, okay, here we have the x dx. But what are we going to do with the negative 2? Well, I could divide both sides here by negative 2. It would cancel out there. I could write it this way. Now, I can substitute for x dx, and I can substitute for 1 minus x squared. So my new integral will be u to the 1/2, right, the square root of u, times du over negative 2. Well, remember, this is just a constant. We can pull that out. Okay, now we can do that. So we have negative 1/2 times, okay, this is going to be, we add 1, so it would be u to the 3/2 over 3/2, and we be, plus a constant. This is an indefinite integral. Okay, so we need to simplify that. Okay, so we have negative 1/2. If there's a fraction in the denominator, you invert and multiply. Negative 1/2, 2/3, u to the 3/2 plus c. But we can't leave it like that. We have to put in the original u. And also we need the 2's can cancel, right? So we'd have negative 1/3 times u, which is 1 minus x squared, right, to the 1/2. Oh, and I forgot. So we bring the 3 halves. I forgot something. Let me do that. Let me write this separately. Okay. So we can cancel that. We put back the u in. Now what I wanted to do, okay, so there's our answer. Do you believe it? Well, what we could do is, if this is correct, the derivative of this should be that. Okay, so let's see if we can get the derivative of this. The derivative, we bring the 3/2 down, leave the negative 1/3 there. We bring the 3/2 down, decrease the exponent by 1. So 3/2 minus 1 would be 1/2, times the derivative of the inside, which would be negative 2x. Okay, so the 3's would cancel. This 2 would cancel with this 2. This negative and this negative would cancel, and we'd be left with that. It works. So this is the method of substitution. Let's do one more problem. Let's do a trig problem. Number 39. Okay, so we're doing number 39. Number 39 is a definite integral. The integral from 0 to pi over 6. Sine of t over cosine squared of t. Okay. Eventually, by the end of trig 2, you would have all kinds of techniques for handling trig integrals. Since the integrals I'm going to give you are going to work with substitution. So usually what you try to do, you know that the derivative of the cosine is a negative sine and the derivative of the sine is the cosine. So it's usually a good idea to, let's say, let u be whatever the power term is, then the derivative of u, derivative of the cosine, is a negative sign. Oh, notice we have sine of t dt. We can substitute that in there. But we've got a negative here, so I'm going to multiply both sides by negative. Now I know I can substitute sine of t dt. I can use negative du. Cosine squared of t. Okay, so our new integral is going to look like, okay, so u to the negative 2, because that's on the bottom, sine of t dt. Okay, now we got to figure out u of 0 and u of pi over 6 to get the new limits of integration. Okay, so let's see, what's u of 0? U of 0 is the cosine of 0. That's 1. U of pi over 6 is the cosine of pi over 6, which is square root of 3 over 2. Okay, so our new limits of integration are 1 to square root of 3 over 2, u to the negative 2 du, and I'll put the negative out here. Okay, well, we can get that derivative, antiderivative. So you add 1 to the top and divide. So negative 2 plus 1 is going to be negative 1 over negative 1, and we're going to evaluate that from 1 to the root 3 over 2. Okay, so, when we substitute this in for u, right, we're going to get this to the negative 1. When you have a fraction to the negative 1, you flip it. There's a negative here, right? But we've also, okay, so, oh, I forgot this. Be careful. Okay, there's a negative here and a negative here, so they're going to cancel each other out. So we're going to wind up with 2 over the square root of 3 minus 1. So that's our area under this curve. Remember, you can check it with your calculator. If you don't know how to do that on even a TI-84 or 82, there are a million videos online that you can find. So the homework is on the notes that I posted. If you want any help, please contact me.